Good morning, everyone. So this is the first lesson for the fourth quarter, which is all about parameter and statistic. So at the end of this lesson, you are expected to distinguish between a parameter and a statistic. So let's define parameter. When we say parameter, it is a measure that describes a population. And parameters are usually denoted by Greek letters. So for population, when we have the mu, the Greek letter mu, population variance we have sigma square, and population standard deviation in symbol we have sigma are examples of parameters. So the statement, the Philippine Senate is composed of 24 senators. So the given value is a parameter because it describes a population. On the other hand, when we say statistic, it is a measure that describes a sample. Statistics are usually denoted by Roman letters. For the sample mean, we have the x with a bar, and we have sample variance, we have s squared, and for sample standard deviation, we have the Roman letter s. So these are examples of statistics. Now, with this statement, for example, the manager randomly selected 35 employees to participate in the sports fest. So that statement, the given value, which is 35 employees, which are randomly selected, is describing a statistic, or because it describes a sample. So may mga key terms tayo dyan like randomly selected or a sample of something like that. So those values or those statements are describing a statistic or describing a sample. Okay. Okay, so let's proceed in the computation of the population mean. When we say population mean, it pertains to the mean of the entire population and is computed using the formula. We have the symbol for population mean, which is mu, is equal to the sum of all the data, given data, divided by the sum of the number of data, okay, or the population size. For example, the numbers of workers in 6 outlets of a fast food restaurant are 12, 10, 11, 15, 12, and 14. Treating these data as population, find the population mean. So the population mean is computed by summing up all the data and dividing the sum by the number of data. So if we're going to add all the data, we'll get a sum of 74, and then the population size, which is 6. So in dividing the two values, we'll get population mean of 12.33. Let's proceed now with the computation for the population variance and the population standard deviation. Variance and standard deviation are widely used measures of dispersion of data in research. The population variance, in symbol we have sigma square, is the sum of the squared deviations of each datum from the population mean. Okay, which is our Greek letter mu, divided by the population size. Okay, later on we'll discuss about the population standard deviation. Okay, for a population standard deviation, it is just the square root of the population variance. For example, the computed population variance is 100, so the population standard deviation will be 10. That is, square root of 100 is equal to 10. Is that clear? Let's have this example. The following are ages of the 16 math teachers at Archimedes Secondary School. We have the following 30, 34, until we have 40. Now compute for the population variance and the population standard deviation. In doing so, first compute the population mean, then subtract the population mean from each of the data. Square all the deviations of the data from the population mean. Then find the sum of all the square deviations. After that, divide the resulting sum by the population size. Take a look with this table. As you can notice, the table is supposed to have like 16 rows with the body of the table, but I just cut it down to like 7 rows. So it's in doing this one, you have to do the completed table in your notes. Okay, so I'll just show you on how to find for the values for the third and fourth column. Okay, so for the third column, all you need to do is to find for the difference between each datum and the population mean. So as you can see, if we're going to add up all the given data, we'll get a total of 548. And then divide that by 16, population size, and we will get 34.25. So we have here for the first row under third column, we'll get negative 4.25. And for the second row, we have 34 minus 34.25, we'll get negative 0.25, and so on. Okay, okay, nakukompleto niya. And then for the fourth column, we have the square of each deviations. So we have here fourth column, first row, negative 4.25 square, and that will give us 18.0625. Since the deviations, each of the deviation will be squared, all the values in the fourth column are positive. Then after squaring each deviations, add them up, and we will get 235, exact 235. Now do this as well, double check it in your notes. So here's the summary of the computation for our given example. So the population mean is 34.25, and then we have population variance. Yung numerator natin makikita yun sa sum ng value sa last column natin. Okay, then divided by the population size, which is 16. So we'll get 14.6875 or 14.69. To make it formal or to make it organized, always round up your answer to the nearest hundreds. Okay, and then for the population standard deviation, just the square root of the given value, then we'll get 3.83. For the sample mean, it is the average of all the values randomly selected from the population. That is, we have here sample mean, the one with a bar. So we have the sum of all the given data divided by the sample size. For the sample variance, we'll be using the following formulas. We have S squared is equal to, still, kung mapapansin niyo ang pinagkaiba lang ay yung denominator natin in which we have n minus 1. Okay? The same process lang din later on sa paggamit ng mga formula natin. And then, for the sample standard deviation, that is only the square root of the sample variance. So we'll have example of this one, of using this formula in our virtual class. So see you and come prepared.